Kevin from Sphero,
I'm Jeremy.
and we are broadcasting live from the Sphero headquarters, the cyclone bomb of 2019.
2019.
So back in my day, we just called it a blizzard, but there's a huge blizzard out, but we still managed to make it here to chat with you guys a little bit. So yeah, we're going to be talking about the EDU app today. But first, I want to thank everybody who's backed our Kickstarter campaign. It's been going really well. We're still overwhelmed with the response, and I'm looking at it now. We have 2,700 backers, which is fantastic.
Pretty phenomenal.
Thank you guys so much. So we've done a bunch of different live streams covering all sorts of different stuff throughout the course of this campaign. And what we want to talk about today is the EDU app and how much time and effort and development has gone into that. So I'm sure you've seen with Rover, probably one of the most exciting new features with Rover is its expandability. So you can add stuff like a Raspberry Pi and Arduino and all sorts of really cool advanced type of development with Rover. But what we haven't talked a ton about is what you can do without even adding anything on it. So it's just kind of like this standalone out-of-box experience. And all of that is based on the Sphero EDU app. So the Sphero EDU app is something that we've been developing for 7 or 8 years and fine-tuning exactly how it works. And over that time, we built up a huge ecosystem with over 1 million programs. There's tens of thousands of teachers on here. There's a super vibrant, active community building all sorts of different fun programs on there. And of course, it has evolved over time quite a bit. So every time we release a new robot, there's typically more sensors in there. There's new sensors that we haven't dealt with before. And every time we add a sensor, we add that functionality to the EDU app. So for example, this is our robot Bolt that we released last year. And maybe you could talk a little bit about what we did to the EDU app to incorporate some of the new features of Bolt. So
Sure.
Maybe starting with the new added sensors and then how that trickled into the EDU app and how people take advantage of that in the app.
Yeah, definitely. So Bolt is our latest classroom robot that came out back in September. And moving, kind of advancing forward from our Spark Plus platform, we added quite a few more sensors as well as a massive battery that kind of really makes this one of the best devices right now for the classroom. But with the Bolt, one of the most noticeable things right here is an LED matrix, so 8x8 LED matrix. It's totally programmable. You can animate, you can print text, a lot of really cool stuff that you can do there. But in the added sensors, the first one is our infrared. And so that allows robots to talk to each other. So bolt to bolt communication and now bolt to rover communication. So you can create some pretty dynamic programs, games, activities around that. Another is an ambient light sensor. So the ambient light sensor measures the actual illuminance that it's receiving over a given period of time. And then based on that illuminance, you can actually create conditionals that will tell the robot to do something. So a lot of the fun ones we've been seeing lately is, turn on the lights and the program starts, turn off the lights, the program starts, things like that. And then the other one is a magnetometer. So that's now integrated into our IMU that allows our robots to calibrate their orientation according to magnetic north, which is pretty cool. Makes it easy to drive and aim, as well as create some pretty slick programming in the classroom. But yeah, from there, we had what we called Lightning Lab a couple years ago. It switched to Sphero EDU. But each time we add a new feature to a robot, we have to update the app to make it programmable. And so what we do is we try to create blocks that make it easy for students or programmers of all ages to begin to utilize the functionality of their robot. Whether it be something as simple as moving the robot in a shape or rolling it across the floor, to creating dynamic programs where the robot's actually sensing the room around it, and then creating conditionals based on that allow the different sensors to actually create a more of a lifelike experience for the robot and the student.
That's cool. So for people that are just starting out, maybe you could walk us through like what's a programming block, what does it do, and maybe
Sure.
walk us through what's like the starter program that people write when they first take a Bolt or a Rover out of the box and they want to get started with doing a basic program. How does that look and what blocks do they use?
Okay, definitely. So if you're not familiar, there's a lot of different block-based programming platforms out there. So it's a visual-based programming. Instead of typing in your syntax or your code, whether it's JavaScript or Python, something like that, you're actually using these visual blocks that are essentially a bundle of different code already pre-made for the user.
It's like a set of instructions for the robot, right?
Yeah,
So
exactly.
Like a block is like do a thing. When it reaches a number or value, do a different thing, right?
Exactly. Yeah. And so it just makes it makes the interface easier for young programmers or beginning programmers to understand that logic, that sequential order that programming requires. And so a lot of our students, a lot of our users of our robots, whether they're at home or in school, end up drawing a square. That's like the first program we do. You know, if you're typing in HTML, I think you probably remember the Hello World. You know, you made your first website and it said Hello World at the top. Well, with Sphero robots, we like to have them program a square. And so there are some primary blocks that most users use. And within the different categories, we have one called movement, what actually controls the way the robot moves on the floor. And the very first block in that movement category is called a roll block. And a roll block allows you to manipulate the robot's heading, speed, and the duration for which it rolls, which is a real easy way to get it to roll forward for 3 seconds and stop, those kinds of things. But what we do is we have students actually help learn how Sphero or our robots see the world, which is in 360 degrees. So they'll roll forward, new roll block, have it roll to the right 90 degrees, have it roll back 180 degrees, and have it roll left at 270 degrees, and it completes that square. But what a lot of users will realize is it kind of rounds those corners, so we introduce what's called a delay block. So delay block allows the Sphero's momentum to come to rest before continuing on to the next line. And so you have those nice sharp edges, and it just kind of helps, because it's a ball, helps kind of stop that wobble and then begin the next part of the program.
Nice, that's cool. So for some of the new features that we added with Bolt, so let's take the IR for example. So we talk about bot-to-bot communication, swarm programming, follow, evade. Maybe we could walk through like a couple of those different things. So let's say you have a Bolt and a rover.
Sweet.
What would that like if you just wanted to do some like a basic example to say like, hey, let's test the IR, let's see how that works. How would I write just a basic program? Let's start out with like bot-to-bot communication. How would that work?
Yeah, so we've actually made it really easy for our Bolts and now our rovers to communicate with each other. It's a matter of just like 1 or 2 blocks per program. Obviously each device, whether it's the rover or Bolt, they each have to have their own connected programming device. But the programs that are created for those are very simple. So if we're just kind of sending a message, we have a program or a program block that's called send message, and we have various channels that they can send that message on over the infrared spectrum. And then on the other robot, we just simply create a program that has the on message received event. So a very basic function that's already created for you. You drop that in, and then you add whatever you want it to do once it receives that initial message. You could have it spin, dance, animate the matrix, whatever it might be. One of the activities we like to make is kind of a cat and mouse. So maybe when the message is received, the Bolt might be the mouse and rover's the cat, and Bolt recognizes the cat's in its way, so the mouse takes off. Yep. So things like that, very simple programming. Another one we have follow evade, like you mentioned, which is 2 blocks. 1 block for rover or 1 block for Bolt, and you set that up. You set 1 to follow, and all that does is it looks for one of the broadcasts that the robot's emitting, and this will just follow it around like a puppy all day long until the program stops. It's pretty simple, very easy to make, but super fun to watch. That's
really cool. Yeah, and so another thing that we added with Bolt is the matrix that you touched on a little bit earlier. So let's say we wanted to do a basic animation on the matrix. Can you walk us through what that interface looks like as well?
Yeah, so we have a matrix animation panel or window that opens up when you go into the matrix block. It's a very simple block, opens it up, and it just gives you an 8x8 grid of the circles. You're able to change the color to anything within that RGB spectrum, so you have just about every color there available for you at your fingertips. And then it kind of uses a classic form of animation where it's page by page. Remember the old like Disney movies, they have to flip through the pages to make the drawings. Well, we do the same thing, so it's frame by frame. So you can actually draw your shape or figure or letter, whatever it is, on the first frame, and then you can duplicate that or go to the copy to the next frame, and then you manipulate that and you continue to do that until you have your 20-30 frames that create that animation. You simply hit start, and now your robot will run that animation. And we have some built in to make it easy for users to see how it works. and you can actually edit the ones that we have built in, so you can kind of explore before you start making your own.
Yeah, so it's like the old flip book style
Yep.
animations. Yeah, super fun. So with Rover, we're actually going to leverage some of that tech that we've built into the EDU app, because there's so many LED lights on Rover. You've got side lights, forward lights, back lights, you got top lights on the PCB. And we wanted to make like a cool way that you can actually animate the lights on the Rover, so that, you know, you can have it, you know, spin lights around or change colors, alternating, like, you know, police lights and stuff like that. And so we're tossing around the idea of using that same interface to program, you know, an 8x8 matrix to program similar layout for Rover, but for the different placements of the LEDs. So it's really fun to be able to kind of leverage, you know, the learnings from Bolt, and then, you know, add that into Rover, and then we already have like this really cool, you know, tested, polished interface for users.
Right.
So with Rover, Rover has all of the same sensors as Bolt. It doesn't have a matrix on it, but we did add a color sensor on the bottom of Rover. And so the color sensor is basically the same technology that we have on our Spectrums rings. And the color sensor is going to allow us to write all sorts of cool programming blocks based on what RGB value is being detected underneath the Rover.
Right.
And so we're still, you know, we're still testing a bunch of different ways of how we're going to implement that. But some of the things that we're imagining is, you know, we've talked about this in previous streams, and we even have a demo of it in our video. But we have something we're calling like chameleon mode, where whatever RGB value that the color sensor is detecting on the bottom, it's going to change all the LEDs on the Rover to that color. Cool. So you could, you know, hold Rover up to like a painting and move it around, and Rover will change, you know, whatever color it's detecting on the RGB values. We can also add sound in the EDU app pretty easily with the sound block. So, for example, imagine taking like 6 different pieces of construction paper, laying them out across a classroom floor, and then writing a program where Rover, you know, drives across those at 1 speed, and each color it'll change the color of the bot, and then maybe play a note in a scale. And so the faster you drive it, the faster it plays the scale, and, you know, maybe back and forth. Or you could change the notes to maybe play, you know, a melody, or, you know, all sorts of different things. It could play, you know, the areas in the town that it's driving to, if you were to create a map or something.
Speak out directions.
And we're thinking that there's going to be a lot of cool stuff that we see people do with it, from, you know, just all across the classroom. And actually, maybe that's a good thing we could talk about from there, is like, some people look at robots and coding and say, you know, oh, that's more of like an after school club sort of thing, or, you know, it's not really for me as a teacher or my class, or maybe I'm a parent with kids, or maybe I'm just a learner of any age and I'm not really into robotics and programming. We've seen something incredible happen over the years with the EDU app. People don't use our robots just to learn how to code. In fact, the robot and the code is really just the vehicle to learn about anything. It just makes learning a hands-on experience. And so I know that you work super closely with teachers and school districts, and maybe you could share a little bit about, you know, maybe some case studies or some examples you can think of creative ways people use stuff like color sensors or IR sensors, or even just basic block programming to learn about all sorts of different subjects.
Yeah, for sure. A lot comes to mind. Like you said, that's my primary role, is to work with classrooms and students around the world. But one of the biggest things I've seen that's kind of been an evolution of what Sphero and programming is in the classroom is that computer science isn't so much a subject anymore, but a frame of mind. If you think about it, you know, that scientific method is all around us, from everything we do, to choosing a new restaurant, to, you know, reading a book. We use that, you know, ask a question, devise an experiment, and then, you know, analyze the data, so to speak. But we do that everywhere. So helping teachers see that computer science is more of something we do on a daily basis, regardless of the subject matter, really helps them see the usefulness of these things, these types of tools in their classroom. And there are a couple examples. I'll give you one real quick that I'd really like to share out. There is a classroom teacher named Rich Perry back in Long Island that he's a high school English teacher, actually, but he uses Sphero robots almost daily. And what he does is he tries to create these experiences where students are having empathetic experiences that allow them to relate more closely to the characters in the books they're reading. So one prime example is they did The Grapes of Wrath, and he created this mound that was virtually impossible for them to program an Ollie or a Sphero robot over. And the kids were getting really frustrated. They're like, man, no matter how hard we try, we can't seem to do it. And one day, they're all reading the book, it just clicks, and somebody says, oh my gosh, this is like the mountain we're building, or we're trying to drive over. And while, the Great Depression and programming in a middle class school is very different, but the fact that the students understood that sometimes no matter how hard you try, it doesn't work out. So they had that empathetic connection now with the characters in their book that kind of helped them stay more interested in the novel, as well as more engaged in the programming activities they did.
That's really cool. So he did this. He like planned this out in advance.
Yep.
So they would like have that feeling, and then when they read the book, they're like, "Oh, I felt this before."
Exactly.
That's really cool. Yeah, and I'm glad you brought that up. Like, we think of our robots and our app as a tool to do something, to build something, to go create something, right? We don't think of them necessarily as an end in of themselves. It's not really all about the bot, whether it's Bolt or Rover. It's not all about our app. Really, it's about what you can do with that stuff, and we've seen some incredible things. Like maybe what are some other things you've seen? I know people use it like, from primary school, learning about like the 4 seasons, or learning about different language arts subjects, and then all the way into high school. Maybe you could give us a few other things that you've seen.
So it's sequencing is an initial understanding of computer science, understanding a proper order of things. And our lower grade students, kindergarten, first grade, a lot of their curriculum is all based on sequencing, understanding the order of numbers, days of the week, months of the year, things like that. So being able to bring those two together makes a really meaningful connection. So being able to create very basic programs, whether it's with our draw canvas or with basic blocks with our younger students, they begin to understand that there's an order to things, whether that's understanding the seasons or the way a program runs. It's a real simple integration. So we've seen a lot of the lower grades do that. We've seen a lot of our kind of upper elementary, middle school classes do a lot of project-based stuff where they're having to engineer something for Sphero. So a lot of activities involve, using a Bolt or a Spark Plus as the motor, and then having to create something around it. So like a chariot of sorts that the robot pulls through it.
Cool.
So completing different tasks, whether it's collecting, turning Sphero into like a snowplow to collect cotton balls on the floor, to having to transport, a 3rd grade class I worked with transported jelly beans to sick sea turtles that were supposedly in one of the storage rooms, that they had to create this rover and follow its path to do that. But we see even deeper integration with math where teachers are creating these massive coordinate planes on their floors, and students are creating programs that represent a particular slope, or they're analyzing linear equations, and they use the robot to give that physical feel to that learning, which typically is 2D, just pencil and paper kind of stuff. Yeah. But now there's an integration of other skills and experiences that are going to be just as valid as learning linear equations, but that they can then take into other areas and use as a way to demonstrate their learning.
That's cool. Yeah, I mean, it just makes everything hands-on,
right?
When you're a busybody in the classroom, it's just fun to get up and see stuff happening in the real world. So
definitely.
That's really cool. So you mentioned also like draw and block. Maybe we could kind of take a step back really big and just talk about like that, which we say a lot, like draw, block, and text, right? And so maybe you could walk through those different, just like really briefly, what those different things are in the EDU app. So for example, if I'm a backer and I bought a rover, but I'm not super technical on the programming side, and how do I get started with the EDU app? What am I going to see, and what will I be able to do as it relates to draw, block, and text?
Yeah, definitely. There's 3 different ways to program in the Sphero EDU app. The first one is draw, which actually allows you just to simply draw a gesture or whatever it is on the screen, and then you hit start, and your robot will actually follow that path on the floor.
That's cool.
And you can change colors and speed and things like that. So very basic, but it's also based on linear progression. So if a student draws a line over here, then over here, it's going to do that in order. And then from there, you can graduate into blocks, where you begin to actually control the conditions that cause it to move, things like that. And then as you evolve from there, you can jump into our JavaScript text editor that allows kids to actually take their understanding and logic from the blocks and bring it into actual programming that they'd be able to use, whether it's for back-end web development or front-end web development, whatever it is they're doing with JavaScript. And then now with Rover, we bring in so many other languages because of the hackable nature and all the different components we can add to it through the UART. It really opens it up to the languages our students can now use within this platform.
That's really cool. Yeah, so maybe we could go to a few more questions. And then we're going to take a quick little 2-minute break because we're going to switch over and show you guys, 5-minute break. So we've been planning an incredible event here at Sphero that actually goes live tomorrow. It's the Sphero Rover Kickstarter Hackathon. We've set up some really cool stuff. So we've been talking about what you can do with the EDU app, what you can do with Rover, and it's all about doing things with these tools. And so we've set up a bunch of really cool examples that we're going to be running through with the hackathon participants, and we're going to give you guys like a super quick sneak peek that no one's seen yet about what we're going to be doing on the hackathon tomorrow, which will be really fun. And yeah, okay, so let's go to a couple of quick questions, and we'll take a 5-minute break, and then we'll come back and do a sneak peek of the hackathon stuff. So let's see, questions. So let's see, Deb is asking, she got an email saying that for every 5 rovers sold, you will donate one to a school. How do I get to be one of those schools? I love this rover. Title I school always in need. So yeah, we actually have a couple backer levels right now where if you buy a robot, you can actually give a robot to a school of your choice. And then we're always, you can always email our EDU team and let us know what you're doing and what your need is, and we can always keep that in mind. We're always doing stuff like that, getting robots out to as many schools as possible.
And Deb,
No, go
Deb,
ahead.
real quick, just want to invite you to check out our initiative with Code Forward and Facebook. So just do a quick search for Code Forward, FWD, and Sphero, and it'll bring you up to a website and check that out. And we're trying to increase access of these tools to our underserved and underprivileged communities.
Well,
so
same with Donors Choose as
correct,
well, right?
yeah.
So there's a bunch of stuff out there you can look at, and we're always doing whatever we can to get robots out into as many hands as possible. So thanks, Deb, for the question. Is Spark as durable as Sphero 2.0? Yeah,
Definitely.
Right. So so is Bolt. So these ball robots are built to be super durable. They're waterproof. They're fast. We drop them all the time. So yeah, super durable. And then we'll do one more question. How fast is Spark Plus?
At top speed, like after it's given some distance to travel.
At full charge?
At full charge is close to about 4 miles an hour.
Yeah, it's about 2 meters per second.
Yeah.
Which Rover is actually going to be slightly faster than that on full charge. So it's pretty crazy fast, especially when you're using it indoors. It's pretty cool. So all right, well, guys, thank you so much for tuning in. Again, we're going to do a 5-minute break here, and we'll do a little countdown. So stay right where you're at. We're going to go set up to do a preview of the hackathon. You're not going to want to miss it. And then we will see you guys all tomorrow at our live stream for the hackathon. We're going to be streaming all day. It's going to be an insane, awesome event. So thanks, guys. See you in a second. 5 minutes. Don't go anywhere. That project mobile. Rover works with our Sphero EDU app. You get the rich experience of our community and our EDU ecosystem.
You don't have to assemble anything. You can start coding right away.
You get a complete polished product, and then you've got the ability to expand and build it into anything you want. It's got all-terrain capabilities. We've got high torque motors with a high gear ratio, which allows it to go fast, but also allows it to go really accurate at slow speeds.
If something disrupts the treads, or if one tank tread moves at a different speed than the other, it'll still go in the heading that you originally intended, which is something unique for tank-treaded vehicles.
The driving experience is unlike anything you've ever seen before.
We worked really diligently to make sure this gearbox was robust. We made sure every single gear tooth would be able to withstand mulch or rocks.
We have infrared communication that you can use to talk to other robots, other rovers, or even our bolts, so they can send messages to each other, play tag.
We've got an ambient light sensor inside, so it can detect, different light values and behave differently.
Rover includes a 4600 milliamp hour battery, rechargeable via USB-C.
We knew this is first and foremost a tool, and you need to be able to swap out a battery in a tool.
Underneath, there's a color sensor, which allows you to detect the color value that it's driving over and write programming based on what color it detects. It's got a full 9-axis IMU, so we've got gyro, accelerometer, magnetometer.
This is the platform I've been waiting for. It has the accuracy, the precision, the durability, the SDK, the low latency communication. It has everything you need to actually accomplish your mission. Don't just move around, but go do something.
Everything from the gear ratio to the clearance underneath to how you hold it, how you interact with it has been thought through.
We didn't just choose the cheapest option, we chose the right option.
We wanted it to have personality and be approachable and draw people in.
There are a lot of competitor products that are really cool bots, but you have to do a ton of work to get it up and running. Or it's super easy to get up and running, but then it doesn't do that much. The thing we're really trying to do is make something that right out of the gate you can get started, but you can kind of keep going with it for a long time.
Rover is built for you guys. We want the hackers and the makers and the students out there to take it and make the coolest projects out there and help inspire us.
Get a Rover. It's awesome. I am getting a Rover. Probably more than one. You should also do that.
Don't you want one of these? Rover, you're so beautiful.
Help us get the best looking robot in the world to market.
I'm hoping that people enjoy it and use it in all sorts of ways that I never expected.
Thank you so much for checking this out, and we look forward to seeing what you guys do with Rover. Hey, you give us a thumbs up too. All right, hey guys, we're back just as promised, and I'm standing here with the infamous Quinton, who has been helping set up the amazing hackathon event, which is going to be going live tomorrow. So why don't we just do a quick overview of what we're going to be doing at the hackathon?
Sure, that sounds good. We're really excited to actually host some of you guys here tomorrow. It's going to be a great day, and we have 4 amazing challenges for you guys. So let's just go take a look real quick.
Sure, where to first?
So we're going to go in this first station over here. So as we're still setting it up, we have this weather challenge where a rover will have a weather an anemometer, which is a wind sensor, and the job is to actually create some wind in there, and then we'll just go in a straight line and go as far as possible. Then we're going to move out to the next challenge, which is kind of over there. We have a color maze challenge, which is a challenge where it's going to highlight the color sensor in rover. So what we're going to do is rover will just drive around on these tiles of colors, and then depending on what it's reading, it's going to just change the direction of it a little bit. Then we have an extra challenge over there, the third one, which is the microbit moth challenge, which is basically using the microbit sensor as a light sensor, and we're going to have different lights around and the track to go towards the lights autonomously with the microbit. And the final challenge is called the bolt bypass, where we're going to highlight all the bolts and rover communication between the two of them. So the challenge will be to escape a prison where a bunch of bolts will be patrolling, and you have to disable them with rover with the infrared and go to the exits.
That is awesome, Quentin. Thank you so much. And we're not going to show too much, so you want to be tuning in tomorrow to check this out. We're going to be live streaming the entire day. It's going to be amazing. You're going to want to be there. We're going to be giving out prizes. We've got all sorts of crazy stuff planned, and it's going to be an awesome day. So make sure you tune in. We'll be getting up close and personal with all these different challenges that you've set up, and they look really fun. People might actually pass out on the weather windup.
This is super exciting, guys. We can't wait to see you.
Yeah, okay, so what we'll do next is we're going to, actually one of the challenges uses the EDU app block programming stuff that we were talking about earlier. So maybe we could go over and you could walk them through just like a high level view of what they'll be doing with the block programming. So let's go back this way.
So as I was mentioning earlier, Bolt is going to communicate with the rover. So we decided to use the EDU app with the bolts right here. So I have 2 bolts set up in this program that you can see right there. So I'm going to start the first one. The first one is a test program that basically if it reads an infrared message, it's going to turn red. And I'm going to have my patrolling bolt over here on this side who's going to be starting driving. After a few seconds, it will flash some colors and get ready to emit that infrared message that will disable, as you can see here, the bolt with the red LED. So what can the bolt here, the test bolt, do to prevent these messages from happening? Well, for instance, I set it up with the EDU app so that on collision, it will emit an infrared message. So I'm going to knock it over here, a little closer to it, and there you go. We are disabling the patrol guard, which is now in a state in which it's disabled. It's not emitting infrared anymore. But beware, if you were to drive Bolt or rover against it and trigger collision, then it's gonna I'm actually going to collide this one. It's going to send the infrared message that will disable you, and this is how you have to be careful about the timing to disable the bolt in there.
That's super cool, Quentin. And you did all this in the EDU app that we were talking about earlier. So we were talking about like some of the basic stuff that you can do, just like driving in a square. This is a great example of how deep you can go just using blocks in our EDU app. Is there a way you could zoom in on this and we could just show like how cool this program looks?
So there are actually multiple parts of this program. So as you can see, we have a very tiny OnStart program right here, which has the logic to do the driving of the robot. And then on the other side, we have the reception of the message 7, that triggers an event that triggers the red LED, the spinning, and then the power disable mode.
That is super cool. So more on this tomorrow, guys. Remember to tune in, check out our Kickstarter page. It's coming up really fast. We got 8 days left on our Kickstarter. We've got some awesome surprises for you guys tomorrow, so make sure that you tune in. And yeah, thank you. And we'll see you guys tomorrow.
We'll see you guys tomorrow.
All right, guys, take care. Rover is a professional level robot at an entry level price.
With this robot, we let you connect at the exact same level we connect to it through UART, through our actual binary protocol that we send. So you can do really anything you want. If you want to make something that just drives from here to here, it drives straight, it drives well, you just call a single command and it's done. And at the same time, we get to expose something really low level.
We're going to have open SDKs, not only for Raspberry Pi, Microbit, but as well as Arduino. And eventually, we're going to have open SDKs for iOS, Android, maybe even Windows or Mac OS. We're not only going to just provide the documentation of how to use our SDK, but we're going to provide you a lot of rich content, a lot of samples and examples of how to get up and running, not just using Rover in itself, but how to integrate it with third-party boards, how you're going to integrate it with additional sensors to get you to the point where you can take an idea and build it.
A lot of the other robots you see on the market are either cheap toys that fall apart right away, they don't stand the test of time, or they're super expensive and the learning curve is really high.
Even for the maker community, it'll make hardware less intimidating. There's a lot of software folks who just want to make a really cool robot or have a really cool hardware platform, and I think we're saving them time and energy to get to the important things.
To get a robot to drive straight, be precise, and have really low latency communication, we're talking a lot of work.
It's difficult to debug a control system because if something goes wrong, you're not sure, was the motor too fast? Were the encoders wrong? Was my control system wrong? And getting those all just right is a significant amount of work. One of the things that I liked playing with at first when I was using it was to make it drive in a perfect circle. The radius was exact all the way around, and it just went in a circle after circle. For a consumer product that's running on rubber tank treads, I think that's pretty exceptional.
It is the product of, dozens and dozens of people over thousands of hours putting our best foot forward in 8 years of robotics experience all into this robot.